Hey everyone, welcome to my talk, Botting for Apple's Initial Access Techniques for macOS. What kind of motivated me to do this talk was I know that typically as red teamers and pen testers, we have a lot of experience with Windows endpoints and working against Windows, but not much for macOS. And so I've been in the process or been in the situation where you set up your infrastructure, your Metasploit C2 or Cobalt Strike C2, and you have a phishing campaign that you send out, and then you start seeing clicks, but they're all coming from iOS or Mac OS devices. And so that just throws a wrench in the whole operation because you don't have anything prepared or set up for Mac OS. So hopefully this serves as a kind of a primer for or introduction to Mac OS techniques. Um, all right. So just a little bit about myself. I'm currently a senior offensive security engineer for Zoom. I've been a red teamer for about 5 years. And during that time, I've worked on several different projects. One of my favorite pastimes was working on the Empire project, which was a post-exploitation framework that was built on or built focused on PowerShell and Python for Windows and Linux and Mac. So I did that for a little while, but I also like to do a lot of or build a lot of offensive tools. So initially, I started with PowerShell. That was like my first scripting language. Then I moved on to C Sharp and some C++. And then when I got into Mac OS kind of security research, I started doing more Python, Objective-C, Swift, and a little bit of JavaScript. Um, and like I said, the past 2 years I've spent focusing on macOS security research. Um, I initially started with Windows in my career, but I kind of gravitated towards Macs just because there wasn't a lot of attention on Macs and not a lot of focus. And that kind of just drew me towards learning about Macs. Um, and so that's kind of what I've been focusing on. All right, so for the talk, today we're going to cover some basic macOS terminology and then go over some of the older and also new security enhancements that macOS has that makes it difficult to phish. And then we'll also cover three of kind of my go-to phishing techniques that I've used over the past couple of years, and then we'll wrap it up. So just some brief terminology. On Windows, we have executables or exe files. These are files that are, that you double click and run some kind of application or code. The same exists on macOS. It's just called a Maco. So a Maco is like a standalone binary, but you also have dot applications. These are essentially folders that have a bunch of or a collection of files, including a macro that's embedded within, where if you double click on that folder or the icon for the application, it'll run the executable contained within. And then you also have dilibs on macOS, and these are the same as DLLs. They're just libraries that contain extra code that will be called upon by the hosting application at runtime. And then you also have Windows services. These are typically services that are set to run at startup or run whenever a user logs in or on demand. And so the same exists on macOS. They're just called launch daemons and agents. Launch daemons are owned by root, while launch agents are usually owned by the user. Now, when it comes to interprocess communication, on Windows, you have Windows RPC. And so this is the remote procedure calls. And this is just applications that have like an RPC kind of server. They allow you to, or another process to kind of dial in and connect and call some specific code that the hosting application has published. And so, it can execute some specific functionality or, send the application information that it needs. And the same exists on macOS. It's just called XPC. And it works, the mechanism works the same. It's essentially a remote procedure call, but the same thing exists on macOS. And then you also have the Windows registry. Everyone knows that's what normally holds system and application settings on Windows. The same exists for macOS. These are called property list files. And these are special XML files that contain application metadata, such as the bundle ID or the name of the application. It can also contain specific settings for, like, does the app use TLS or SSL? Or does it need an exception? Does the app, subscribe to Apple events? Things like that will be stored in the property list. And the other difference, or the main difference from Windows, is that the registry is in one central location, but property lists usually exist within each application bundle, or they're embedded inside of a macro binary. Now we'll talk about some of the macOS security protections that you'll commonly see or encounter if you're performing like a phishing engagement or just trying to get initial access against macOS endpoints. The first of which is Gatekeeper. Gatekeeper has been around for a while. This is an old security mechanism that Apple has put in place. And essentially what it does is every time you download a macro binary or a file or an application from a browser or through a mail client, that file gets tagged with a special file attribute. And this is like an extended file attribute. It's not anything that you can immediately see when looking at the file, but that attribute is called the quarantine attribute. And what this does is this tells Gatekeeper, which is like a service that's continually running and basically controls application execution. Whenever you run an app or a file or double click it to run it, it tells Gatekeeper that this application or file came from an untrusted source. And so Gatekeeper will present a prompt to the user to basically warn them and say, hey, are you sure you trust this file to run? Like, is this something that you're sure you want to execute on your Mac? It could be a virus or malware. So just double check. And so that's essentially Gatekeeper's role in protecting your Mac. And it's a common issue because the prompts that are presented to the user are dependent on whether your application is signed or not. So one of the kind of workarounds that you can use to get by this is basically just telling the user what to do. So in your phishing pretext, like, you can include, instructions that say, hey, when you're trying to run my application, you need to right click and click open. Now, doing this on macOS for a quarantine file, all this does is it will prompt the user and basically ask them, like, hey, are you sure you want to open this? And just to note, that behavior was prior to, I think it was like 10.15, where notarization was introduced. And so prior to 10.15, a user could right click and open a unsigned app, and Apple will basically present them with a prompt that says, are you sure you want to open this? And that was it. Like, the only thing that would be different would be like they would present like the warning symbol with the prompt, and that was it. Now, since 10.15 and notarization, Apple will basically block that application from running outright. Even if you right click on it, it'll just say, hey, Apple wasn't able to verify that this application doesn't contain any malware. Now, to kind of touch on notarization, this is a process where Apple will essentially check your code for any compiled app or file that you provide and determine if it has malicious code or not. Really, I don't like this is a great idea, but its implementation isn't that great. There's been several security researchers that have already proved that you can upload known malware samples to this notarization service, and it gets through fine. Like, it just gets notarized and it's fine, and Apple says nothing's wrong with it, even though it's a known malware variant. And this is like for Flash malware, for pretty popular malware variants that target macOS. It just gets right by. And so, you just start to question, like, what is this really doing? Because Apple doesn't give any insight into what notarization does. But the only advantage for you as a red teamer when it comes to phishing is that if you have a signed and notarized application, you don't have to deal with Gatekeeper, because Gatekeeper will essentially say, hey, this is all good here. There's no worries. It will just present them with one prompt that looks slightly different from the others, and I'll go over that next. So you can see on the left, this is a prompt that you'll see if your application is unsigned and not notarized. When the user double clicks it, this is the prompt that they'll see. It'll say, hey, We weren't able to verify this app doesn't have malware. Um, are you sure you want to open this? And then if it's unsigned, you right click on it and click open. This is the prompt they'll also see. So it's still kind of the same, but it gives, gives the option to open and run the application. But if you're signed and notarized, the user can just double click on the file and Gatekeeper will let it pass. It'll say, hey, like, do you want to run this application? It'll give you the application that downloaded and a timestamp. Um, and then also you notice that they switched the buttons. Now the open button is on the right and it's highlighted by default. So that's just something to note. Now, the next security protection that's pretty common to deal with is the application sandbox. So just like any other sandbox that you see, like for Windows, basically the sandbox places the application in a special container that restricts your access to various system resources. So in terms of files, basically you're only allowed to read and write files by default inside of the special folder that's given to the application within the sandbox. And so you don't have access to like the desktop, documents, or downloads, or any other folder on the system, unless there's an exception in the profile. Also, peripheral devices, so like camera and microphone, you don't have access to those. And even then, you still need to get past the privacy controls. So the user has to explicitly give you access to the microphone and camera. Um, and in terms of networking, generally, like all networking is blocked unless you specify or allow it to, make outbound network connections or inbound or receive connections inbound. And then there's XVC services. Now, by default, every application, even inside the sandbox, can talk to the central launch XVC service. This is the main service that's responsible for starting like every process on a Mac. Every child process is spawned from the launch service. And so that is one XVC service that you can talk to regardless of whether you're in the sandbox or not. But it'll restrict any other service. So you won't be able to connect to, just some other service you may need to talk to. Now, in terms of Sandbox Escapes, there's been several developments over the past like 2 or 3 years. Most of the focus has been on Microsoft Office and escaping that sandbox. And the reason is because typically when you're trying to fish for initial access and you use macros, once your macro executes, it's executing inside of the sandbox. Like you're not going to be able to spawn a process outside of the sandbox or access files that have been restricted. And so a lot of the focus has been on Office because that's a common way to, or a common payload, or sorry, a common application that's targeted for access. And so there's been a bunch of developments. The main idea for the Sandbox Escapes has been abusing login items. So if you're able to place a file or an application in the login items that will be opened by default on the system whenever the user logs in, there's a possibility that you can find a sandbox escape. I know initially there was some research by MDSEC where they found an exception in the Office sandbox that allowed them to create a new service. And so once that service launched, they were executing outside the sandbox. And then the other two more recent escapes were focused on adding a new login item as a zip file that unzips files in specific locations that will allow you to execute code and get outside the sandbox. So you can check those out for more information on those, but those are pretty cool escapes and they're still relevant today. So when it comes to looking at sandbox rules, you can go to the system library sandbox profiles directory and look at all the system or default sandbox profiles for macOS applications. And so when you're looking at a sandbox rule, it'll just be this long list or blob of this custom syntax that they use. I guess they call it like the sandbox query language or something like that. But for every rule, you will see an allow or deny action, and then the specific operation that you're allowed or denied. So it could be like file write, file read, like a network connection, or mock global lookup, which is for looking up XBC services. It could be tie into Apple events, but you'll basically see what operation is allowed or denied. And then beneath that, you'll usually find um, other, restrictions or exceptions that are um, exclusive to that rule. So for this one, you'll see that you're only allowed to file write um, to that sub path or directory, library preferences audio, or you're allowed to write look to this file path explicitly. So to dev dtrace helper. Um, and then in terms of third-party apps, you can find a sandbox profile usually within the application signature, right after the entitlements section. I can't really go into what entitlements are, but that's where you'll find the sandbox profile usually. So now we'll start talking about some of the techniques that we can use to get access to a macOS endpoint. So Office macros are commonly used by attackers because it's a very popular application, and you will usually find these on Windows endpoints, and then you'll see them on some macOS endpoints. Um, Things have kind of changed recently because of the registry and GPL settings that can be used to disable macros or restrict them to only allow execution from trusted locations. So from like a network share or from a specific websites. And then also mail filters have gotten really good, and EDR vendors have picked up on spawning a new process from within Office, which is usually what happens when you run a macro. The attacker wants to get out of Office as fast as possible because you may close the document and then you basically kill their access. Um, then mail filters pick up on macro enabled documents pretty quickly, and that's pretty much changed the game for macros. And then this is the typical kind of process when you're phishing an end user with a macro. You'll have your VBA code added to a benign document to make a macro, and then you'll send it. If it doesn't get blocked by the mail filter, it'll get delivered to the user, and then they open it and they'll get presented with this prompt that says, hey, do you want to enable or disable macros or do not open? That's kind of the basic process for using macros. So now when it comes to getting by mail filters, remote macro enabled templates are awesome. Um, and what this allows you to do is you basically create a document that loads a macro enabled template from another location. And so you can send a benign doc or docx um, or template even that points to some macro enabled template and loads it whenever the user opens it. And so when it goes to the mail filter, they don't see any malicious code and they don't think anything's up. So they're just like, hey, like, let's let this document through. Looks good to me. Um, and so when it comes to editing these, you need to open up a settings XML file that's contained within the document. So what you'll do is you'll change the extension for the doc to a .zip and then unzip that document. And within there, you'll see within the Word Rels directory, there's this settings XML file. So if you open it up, you'll see that there's a target parameter or target field, and you can change this to point to your macro enabled template. And when you do that, that basically just now weaponizes that document. And so you can send this benign doc through the mail filter as it is, and when the user opens it, they'll get presented with a prompt. And this is just this is a depiction of what that kind of process looks like. So you'll create your macro enabled template with your VBA code, and then you'll save that template on a web server or some remote location that's accessible to the user. And then you'll create another template that's benign, and you'll go through that process of editing it and changing where that target field points to. And then you'll zip it back up and have the document, and then you'll send it to the user. It should hopefully get by the mail filter because there's nothing malicious contained within that doc. And when the user opens it, Word or Excel Word will pull down that template from that remote server and prompt them to enable the macro. And if they do, then you'll have codecs and get your initial access. You still have to deal with the sandbox, but there are, like I said, sandbox escapes that have been pretty effective as of late. So yeah, it's definitely an awesome way to get initial access. Now, one of my other favorite things is installer packages. With this payload, essentially, it's pretty commonly used across macOS endpoints. You'll see them for updates, like if you download a security update from apple.com, it's going to be in the form of a package or a DMG file, but most likely a package. You also see some third-party apps, they use packages for installers, just because it's easy to deliver. It's a widely accepted format for macOS. There's never any problems. And then you can also use, deployment scripts, and I'll talk about these. These are just bash scripts that you can run inside of the application package. But that also leaves us it leaves it advantageous for attackers because there are several different ways that you can execute malicious code inside of a installer package. So the bash scripts, like I mentioned, those can be two different types, which I'll talk about. And then you have inline JavaScript that can run within a special XML file. And then you have installer plugins, and these are only applicable to component packages. So the types of packages you'll have, or I'm sorry, yeah, the types of packages you'll have are the component packages, which optionally can be payload free. And that means you're not installing any applications or anything. You're just going to execute some pre or post install script. And pre and post install scripts are essentially just bash scripts that either run just before the installation process starts or just before it finishes. And then you'll have also the inline JavaScript. That's possible as well. The JavaScript isn't that great. You can only make like a system call to run some command. So it's not that robust, but it's still an option that you can use. And then with distribution packages, they are basically just a package that has multiple packages contained within it. But with these, you can use installer plugins. And installer plugins are essentially just a extra piece of code that you can include to enhance the installation process. And with those, you can write your payload in native Objective-C or C++, and macOS will execute that plugin for you in a separate process outside of the installer, which is pretty cool. So now this is just the basic directory structure for a package. You have the scripts folder, which has your pre or post install script. Just note that the script has to end with an exit 0 statement. And the reason being is if you don't have that, the installer will think that the script has failed, and then it'll fail the whole installation process. And so that may throw off the user and think that something is wrong. They may contact IT or something like that. So you want to be sure to include that. And then if you do have a payload or an application that you want to install, there is a directory structure that you have to mimic for the target endpoint of where you basically want to install that application. So if it's in the applications folder, you just need to have the root directory, and then underneath that applications, and then within that your application. And the installer will just copy that to that directory. So this is just the command that you can use to create a package. You just specify, if you're not using a payload, you can use the no payload flag. Specify an identifier, it's just a bundle ID that says or describes the bundle or the installer package. Then you'll specify a version. And then if you do have a payload, you'll use the root flag. You just give it a root directory. It doesn't have to be called root. And then if you have a post or pre-install script, you'll specify a scripts directory, and then you'll give it the package name. And this will build a package for you. This is a native macOS command line tool. Unfortunately, it's not on Linux. Although you can build packages on Linux, I just wouldn't recommend it. That's a very painful process. So yeah, so you can use package build to build packages. So kind of the last phishing technique or payload that I'll talk about is mobile config profiles. These are pretty cool. They're also commonly used by sysadmins to configure third-party apps and system settings, and control like some of the security settings on macOS. They are just in generic XML format, and there are tons of options. So they're really useful. Also, one of the main advantages for attackers is that mobile config profiles are not quarantined by Gatekeeper. So a user, when they double click a profile, they will still see a prompt, but it's not coming from Gatekeeper. It's from the system preferences pane. It's just asking, are you sure you want to install this profile? It's going to change the setting. Hey, beware, it's unsigned, whatever. But Gatekeeper is not going to step into that process. So you can also install these directly with Safari or with a native mail app. So it's pretty cool. It doesn't have to be downloaded and then opened. Safari will install it directly from the browser, or if it's through the native mail app, so just the mail application on macOS, it'll do the same thing. You can sign or encrypt these. I wouldn't recommend encryption just because you would need to already have access to utilize encryption for the profile. But signing is a great tool that actually gets you one less prompt for the user if you do sign your profile with a valid certificate. And like I said, there's tons of options that are available. Now, one specific payload can be a Chrome extension. And what this essentially does is it backdoors Chrome so that you can tell Chrome to install a Chrome extension without the user's consent and in the background. And so you'll set up your profile according to the extension install force list settings or format. And then you'll host your extension on some remote web server. And then once you have this installed, whenever the user opens up Chrome, it'll download that extension from the remote location and install it without even prompting the user. Uh, Recently, they've added some things where it'll at least notify the user like, hey, this new extension was installed. But you still won't see like a very like disruptive prompt. And they're also blocked from removing it because when they go to the extensions pane, it'll say, hey, like this extension is controlled by enterprise policy. You can't remove it. So it's pretty cool. There are also some neat capabilities, like you can proxy your browser traffic through another Chrome extension and essentially have access to all the cookies and websites and internal applications that the victim user may use. So it's an awesome kind of a feature. Also, another mobile config payload is an MDM solution. These are pretty cool because if you have a device, an iOS or macOS device that is not already enrolled, you can essentially compromise their Mac and take control without even introducing a new binary or having some kind of like interpreter payload or anything like that. You just send them a mobile config profile that's set up for enrollment, and then they'll enroll their Mac, and then you basically control like all the security settings. You can push installer packages to eventually launch some kind of payload, or you can send like a Chrome mobile config profile to backdoor Chrome silently. So it's pretty cool, and it's pretty easy to get an MDM server set up and get a cert. All it takes is $20 to get the cert because you have to purchase the server app from the Apple App Store. But once you do that, you can easily set up your own certificate and use that with like micro MDM. So this is just a quick graphic to show like the process of backdooring Chrome with a mobile config and getting it to install. So you'll send the victim user mobile config through email, or you'll send the link via browser, and they'll either download it or install it directly from Safari. And then they'll get prompted. And this is the prompt that I was talking about. If it's unsigned, there will be 2 of these prompts. If it's signed, it'll just be 1. And so they'll see Apple will say, hey, like, are you sure you want to install this profile? This is going to change the following settings. And you can even preview the profile and see what the contents within. Now, if you do encrypt it somehow, then when they do show profile, they can't actually see what settings are on there. And so once they install the profile, it'll configure Chrome and set that extension install force list. And so the next time Chrome opens, it'll go and pull down your extension and install it. Another neat thing is that if something happens to your payload and it crashes or it doesn't work, Chrome periodically checks for updates. And so you can update the code that you host remotely, and Chrome will reach out in about 4 or 5 hours and download that extension code and install it. So it's pretty cool. It manages persistence for you already. And that is it, folks. That kind of wraps it up. Those are 3 of the most common techniques that I've used over the years for phishing against macOS. If you have any questions, you can find me on Twitter at Exorier, or you can find me in the BLC Slack at Cross, or you can send me an email. I check emails regularly. Thank you for coming to my talk.